Assalamualaikum and a very good afternoon. Today we are going to discuss about the concept of thermodynamics and its importance to chemical engineering. First of all, let us define what thermodynamics is. It comes from the Greek word which is therm means heat and dynamics means power. So basically, thermodynamics means heat is converting to power. By definition, it is the study of transformation of energy, including power generation, refrigeration, and the relationship among the properties of matter. Next, what is chemical engineering? It is an applied of chemistry. It is a branch of engineering that concerns with construction, design, and operation of machines that related for solving a problem or make a useful product. Now, let us sit back and watch a play that implies the importance of thermodynamics in chemical engineers' life. Let's go.
Okay, good morning students. So, are you ready to learn about thermodynamics today?
Yes.
Oh, so enthusiastic. Okay, so what is thermodynamics? Thermodynamics is the science of energy. So that's why almost all of the applications in chemical engineering deals with energy, and that's why we need to learn thermodynamics, because everything we do in chemical engineering, we use thermodynamics principles. The most prominent example is this one. Can anyone tell me what is this device?
Okay. Convert heat energy into work. Is it correct, sir?
Yeah, correct. So this is the diagram of a old type of heat engine. So this will be the heat source, which will expand and contract the gas inside this cylinder, which will in turn turn this wheel. But the modern heat engine uses a turbine, a boiler, to generate electricity in power plants. Okay, class, so this is the schematic diagram for a heat engine. As you can see, there's a pump, a boiler, a turbine, and a condenser. So the pump is where the work is pumped for the working fluid, and the boiler is where the heat goes in, and the turbine is where the work comes out. So as you can see from this diagram, we are going to put in heat and generate work. So, by learning thermodynamics, you will be able to calculate the amount of heat supplied to the steam to gain that amount of work. So, for example, in a power plant, your boss will ask you to design a heat engine for the plant. So, he asks you, so what is the work we need, which means how much work that heat engine needs to generate, and then how much heat needs to be put in order to generate that amount of work. So class, how can we maximize the efficiency of a heat engine? Anyone knows? No, it's okay. You will learn this in thermodynamics. So to maximize the efficiency, we use this cycle. This is the Carnot cycle, devised by Carnot and French engineer, and he stated that if you want to maximize a heat engine's efficiency, you have to use all reversible processes in a heat engine. Okay, so from point 1 to point 2, that's the region where heat is going to into the cycle. So if you reference back to the diagram, it is the boiler part, where fuel is heated. It's used to heat the steam so that it expands, as you can see. From point 2 to point 3, it will be the adiabatic compression region, where the steam is used to power the turbine, and the turbine will turn a dynamo-like device to generate electricity. Next is point 3 to point 4, where the steam and water mixture will go through a condenser to release heat to the surroundings. And then from point 4 to point 1, a pump is used to adiabatically pump the fluid back to point 1, which is the original state, so that it can repeat the cycle again. So by learning thermodynamics, you will be able to calculate all the energy changes in all four states, calculate the efficiency, calculate how to maximize the efficiency so that you will reduce the cost for your operation. You will save resources. Next, one of the things we are going to learn in our course is phase diagrams, which relates the temperature, volume and pressure of fluid in all the processes. So anyone can tell me one of the unit operations that you have learned that uses the phase diagram.
One of it is an evaporator. In an evaporator, we use steam to heat up the feed solution. Knowing how the pressure affects the boiling point of the steam and also the phase diagram, we will be able to determine how steam will behave during the cycle. We will also be able to calculate the power needed to operate the evaporator and also how to design the evaporator.
Oh, very good. Okay. How about Ganesh? Can you give me another example?
A reactor. Learning thermodynamics also helps us to determine the equilibrium state of any reaction. We will know what is the condition to provide in order to maximize product, the heat needed and also the technique to increase the efficiency.
Yes, very good. Amirul. Hey Amirul, can you give me another example?
What?
Another example of what unit operation uses thermodynamics.
No, sir.
Huh?
No.
And that's why you must listen in class, because this is very important, because not only does it relates to how all the unit operations are operated, it also concerns about safety. For example, if you do not know that the pressure increases with temperature, you will not know that there's a pressure limit for every boiler and vessel in the industry. If you let the temperature increase too much, then the boiler will leak and possibly explode. So that's how serious this matter is. You must know thermodynamics in order to prevent this kind of accidents. Thank you, students.
Okay, good morning, welcome to the company. And for the first task of our interview, I would like both of you to design the heat engine.
Hey, Zabat, I will meet you in this design project. Alright, keep on.
No matter what we do, we can't go back.
Welcome back, Mr. Hudzaifah and Mr. Amirul. Good evening. I have analyzed both the designs submitted to me by Mr. Hudzaifah and as well as Mr. Amirul. Good job, Mr. Hudzaifah. You did a good job in designing the heat engine by considering all the vital elements in the designing process, which includes HSE aspect, cost, and also conservation of energy and resources. Mr. Amirul, I'm very disappointed with your outcome. Looking at your design, I can tell that you designed an engine just for the sake of completing the assignment given to you, since your design is neither efficient or effective. No thermodynamic aspect is implemented. Remember, a poorly designed engine could cause safety problems to many parties, including the workers, the consumer and the general public, and also the environment. The degree of effect could vary from very small scale to a very large scale, which might put the company itself under instability. Although at times the cost of production of a poor engine might be low, however, the cost of effect brought up the engine, such as the repair and the non-reliable product, could be immense. This could cause financial issues of the company itself. Conservation of energy and resource should always be put in front and also in any designing process. Very importantly, the design of an engine must comply to the HSE regulation of the government to ensure the safety and also for the betterment of the society.
I going to my hometown.
Oh, your hometown. Oh, okay. Hey, Nurul, why the pressure is so high?
The higher the pressure, the smoother will be the tire.
It's not how it goes. You know, when you go for a long distance, this kind of pressure, your tire will blow up. You know that? Yelah, suit yourself lah. Okay, see you later.
What happened? Oh no, my tire.
Nurul, what happened?
My tire flat.
Your tire flat. I told you already. It must be because you put pressure so high. You know why? Because your tire, when in this hot and sunny day, you put so much pressure, the gas inside will expand. Okay? The tire has been designed to in a manufactured way. It has a baseline. What is the maximum pressure you can put? What is the minimum pressure you can put, so that the tire wouldn't be flat. Okay? If you want to know, when in a hot sunny day, you should at least put pressure at least a few pounds below the base standard the manufacturer put. Because why? The gas inside will expand. When it expands, it will increase the pressure inside the tire. But when you in a cold morning, you should check first your tire, because in a cold condition, the tire will the pressure inside will decrease 1 psi in every 10 degrees Celsius. It drops. So you should take note of that. Now I know.
Okay, like from what you can see from the previous scene, which is heat pump, reaction equilibrium, and evaporator. All this example is related to the concept of thermodynamics. So we have to know all the properties and behavior of these metals, so we can make a useful system. As a conclusion, we can see that thermodynamics is not only important for chemical engineers, which is in industry, but also important in chemical engineers' life.
Hi guys, so we hope that you enjoy our video, a short video. I hope that you learn a valuable thing from this video. So that is all from us, from me, Amirul AKmal, Fatiehah, and also Ghameswary. So hope to see you again. Bye.